In this video, we'll talk about two different types of notation for sets. I will show you two just because there's a lot of limitations on both, but between the two of them, they can cover just about all kinds of sets, and a lot of textbooks will bounce between the two. So let's talk about set builder notation. And just for an example here, let's say we're looking at the function f of x equals x squared. And I am trying to set or build sets for the domain and the range. So if we think about x squared, rough graph, it's a parabola. It goes through 0, 0, and then it goes back up. So if I'm looking at the x values, the domain, I get them all. So in this case, we're looking at the real numbers. So for set builder notation, I start with a squiggly bracket because I'm talking about a set. And this is where the notation is a little interesting. The first thing you have to do is express what variable we're talking about. In this case, we're talking about x because we're talking about domain values. We're going to draw a vertical line. This line means such that. So basically I'm saying, okay, my domain is represented by x, and here's what x represents. So after the line, that's when I'll say, in this case, x can be any real number. And in this case, that concludes my set. So let's take a look at the range. This one's a little bit different. I only get from 0 up. So again, I'm going to start with a squiggle bracket. In this case, I'm not talking about x, I'm talking about y. I'm going to draw my line. So basically I'm saying I'm picking y, and here's the conditions for y. Well, y is still a real number. That's a pretty common occurrence when we're talking about functions. You'll see this little phrase. But I can't have the negatives. So I'm going to say y is greater than or equal to 0. Now what this sounds like in words. The range can be represented by y as long as y is a real number and y is positive or 0. Now let's talk about interval notation. So interval notation is a little bit different. In some ways it's easier, in some ways it's a little more abstract. So let's again look at f of x equal x squared as our example, and again I'll draw a little sketch of it. Looks like a parabola, goes through 0, 0, even if it looks like I missed it there. Okay, now again we're looking at domain, we're looking at range. Now if we're thinking about domain values, we cover them all. So interval is basically I'm trying to give a span of numbers. So in this case, it's a little weird. It goes from negative infinity to positive infinity. And interval notation makes the assumption that we're talking about real numbers. So it's very useful for functions, especially ones that have weird breaks and gaps. So in this case, we're going to do a round bracket around infinity. Usually the round bracket indicates that it's not included in the set. So if you think about, for example, 1 over x, I never actually get 0 in my graph. So if I was to do an interval notation for that, well, I would have a round bracket around 0. Now let's talk about the range. Again, I get 0, and then every other positive value after that. So I have 0 to positive infinity. I'll do a round bracket around the infinity because we can't ever actually contain infinity. And we'll do a square bracket around the 0 because I do actually attain 0. It's in the set. So that's one example of interval notation. I hope this is enough to get you going.